Okay, lastly, we want to find or want to solve question 1c. Now, question 1c says y double prime or triple prime minus 2 times the second derivative of y, then minus 4y prime plus 8y equals 6x e to the power 2x. So we are told to use the method of undetermined coefficient. So again, like the previous ones we have solved, the general solution is going to be of the form y equals yc plus yp. Now to find yc, we solve the homogeneous equation associated with this dE. So to solve yc, so I want to solve y prime 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 minus 2y prime minus 4y prime plus 8y equals 0. So I want to solve this. Now to solve this homogeneous equation, the first thing I'll do is I'll form the auxiliary equation. So anywhere I find y, I write m. So you have m cubed minus 2m squared minus 4m plus 8 equals 0. Now when you solve this equation, what you're going to have is you have m plus 2 into m minus 2 squared equals 0. So on solving this, so this implies that m equals negative 2 and m equals 2 twice, meaning the multiplicity of m equals 2 is 2. So why is the multiplicity 2? It is 2 because of the power that we have here. That's why the multiplicity there is 2. So having known this, so we're going to use the assumed form for this kind of case to obtain our complementary solution, so which is going to be c1 e to the power negative 2x, then plus, so since it's of multiplicity 2, we'll first start with the normal one, c2 e to the power 2x, and then we write x c3 e to the power 2x. And then from this, now this is the complementary function. So we've already found yc, so it's remaining yp. Now how then do we go about finding yp? Now this is where there are lots of details here. Now 2, so we want to solve for yp. Now so we note that the yp we want to find, since we are using the method of undetermined coefficient, we are going to assume a form for yp. Now to assume a form for yp, it is dependent on the right hand side of the non-homogeneous differential equation. So I'm going to call my right hand side, I'm going to call it g of x which is equal to 6x e to the power 2x. Now if the right hand side is this, now you'll observe again, and a very good way to look at it is it contains two different things here. So this is linear, while this is just an exponential function. Now this is going to help us in determining the assumed form for the particular solution. Now since this is linear, so I'm going to say my yp equals, so it's going to be a linear ax plus b times the exponential function e to the power 2x. Now, but then, before you begin to use the particular solution and make some verifications, you must check or verify that the particular solution or the terms in a particular solution have no twin in the complementary function. Now, if you're going to rewrite this, this is the same thing as ax e to the power 2x plus b e to the power 2x. So let's check to see if there is no twin. And the first thing we have here is we have what's the name, b e to the power 2x, like we can have here, and we also have b e to the power 2x. We have a multiple of e to the power 2x here, and also we have a multiple of x e to the power 2x. The same thing happens here. A multiple of x e to the power 2x. So what we do is we multiply both. We're going to multiply this by multiply a whole thing by x. So that's what we do. So you multiply by x. Let me write that in red so that you can highlight what's happening. So multiply by x. Now when we multiply by x, what we have is yp equals ax squared plus bx into e to the power 2x. Now this is what we still have. And then if you want to write this out, you have ax squared e to the power 2x plus bx e to the power 2x. Now but then you observe again that there is still a repetition. And what is the repetition here? So what we have here is a multiple of x e to the power 2x coming here, and we also have a multiple of x e to the power 2x here again. So that simply implies that we still need to multiply again by x. We keep on multiplying by x until there is no repetition anymore. Now when we multiply by x, what we have is yp equals, you have ax cubed plus bx squared e to the power 2x. Now if you want to expand this, we're expanding just to check that there is no repetition, because it's not really necessary. So you have ax cubed e to the power 2x plus bx squared e to the power 2x. Now this is what you have. Now the first thing to check, this is a multiple of x squared e to the power 2x. Do I have anything like that here? No. So since I don't have anything like that there, this is checked. Now for the next one, this is a multiple of x cubed e to the power 2x. Do I have anything like that in a complementary function? No, there is nothing like that. So this is also checked. So we are good to go. So we can use the yp that we have there. So let me officially declare my yp. Yes, I found a yp. This is the yp that I'm going to use. That is ax cubed plus bx squared into e to the power 2x. Now, since I've gotten my yp and we are assuming that that's a solution of the non-homogeneous differential equation, it implies that based on the assumption, when you substitute that yp into each of these values, we must get 6x e to the power 2x. Now, in an aim to substitute that, I need to find y prime prime, y prime, and the third derivative. So that's what I'm going to do now in a jiffy. So what we have is y prime prime minus 2y prime prime minus 4y prime plus 8y. So having doing that, we have y triple prime 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 minus 2y prime prime minus 4y prime plus 8y. So when we take the derivative and then we take all these multiples together, what we're going to have is